Hello everyone, my name is Yusuf Al-Wakil, and today I will be discussing and going through my final research paper review. The paper is titled Sand Towards High-Performance Serverless Computing, and it was written and presented in the 2018 Usenix Annual Technical Conference in Boston by Istemi, Akkus, Ruichuan, Chen, Ivica, Rimac, Manuel, Stein, Klaus, Satzke, Beck, Paarijaat, Aditya, Volker, Hilt, and Nokia Bell Labs. As we all know, serverless computing has become the new cloud computing paradigm. However, these existing serverless platforms normally isolate and execute functions in separate containers, and they basically do not exploit the interactions among functions for performance. Therefore, this practice can lead to high startup delays for function executions and inefficient resource usage. On some cloud platforms, such as IBM and AWS, the paper discovers how the total runtime is significantly more than the actual time required for function executions. This, in fact, leads to serverless computing by a broader range of applications being severely limited. So why is this still a problem? So there are basically two main issues that lead to the runtime being significantly more than the actual time required for the function to run. So first off, most existing serverless platforms execute each application function within a separate container instance. This leads to two common practices, each of which have a drawback. First one, can start a new cold container to execute an associated function every time a new request is received, and terminate the container when the execution ends. While reducing the startup latency for processing, the practice comes at a cost of occupying system resources unnecessarily for the idle period. And the second main issue is that, which makes the runtime too long, is that existing serverless platforms do not appear to consider interactions among functions. So these platforms often execute functions wherever required resources are available, which lead to external requests treated the same as initial requests, and therefore causing function interactions to pass through the full end-to-end function call path, which therefore provides that extra latency. Some background knowledge is that the research paper discusses and summarizes how past work platforms deploy and invoke functions in parallel as well as in sequence. In serverless computing, the cloud operator takes the responsibility of managing the servers and system resources to run the functions supplied by the developers. With the background knowledge, the majority of serverless platforms use containers and map each function basically in its own container to achieve this goal. This mapping enables the function code to be portable. Serverless platforms that employ such a mapping include platforms like AWS, Lambda, Microsoft Azure functions, Google Cloud functions, IBM Cloud functions, all that. So for functions, calling the most straightforward approach to handle an incoming request is to start a new container with the associated function code and then execute it. Related work showed that to improve startup latency, a common practice is to reuse launched containers by keeping them basically warm for a period of time. And finally, function concurrency is an aspect in which various serverless platforms can differ on how they handle the concurrent requests. Most cloud platforms such as AWS Lambda and Microsoft Azure functions only allow one execution at a time in a container for performance isolation. And therefore, as a result, the concurrent requests will either be handled in their individual containers and experience undesired startup latencies for each container. So some related work. The paper discusses that despite the fact that serverless computing is very recent, it has been used in many different scenarios, such as parallel data processing, data management, and system security enhancement. The paper also acknowledges Hendrickson's work, which was to propose a function named OpenLambda after identifying problems in the AWS Lambda software, including long function startup latency and little locality consideration. The paper also discusses McGrath's work, which was to investigate latencies in existing serverless frameworks. The paper goes on to explain how important these problems are to resolve for serverless applications development, where function interaction latencies are crucial. So the main idea. The research paper introduces us to Sand, which is a new serverless computing system that provides lower latency, better resource efficiency, and more elasticity than existing serverless platforms. The research paper talks about the design and building blocks of the sandboxing mechanism, which actually enables Sand to be resource efficient and achieve low latency function interactions. The key idea of the sandboxing design is that there needs to be two levels of fault isolation. Isolation between different applications and isolation between functions of the same application. With sand, the sand system separates applications from each other via containers so that each application basically runs in its own application. Secondly, serverless platforms normally deploy a unified message bus system to provide scalable and reliable event dispatching and load balancing. This mechanism usually causes unnecessary latencies when multiple functions interact with each other. The way SAND fixes this problem is by creating these shortcuts for functions that interact with each other. The researchers describe this as a hierarchical message bus. So the researchers chose to compare the SAND system with the Apache OpenWhisk and AWS Greengrass software. The reason being was because they were able to run these local installations for a fair comparison. The way they evaluated these systems was the researchers first report on the micro benchmarks of alternative sandboxing mechanism and SAND hierarchical message bus. They then evaluate function interaction latencies as well as the memory footprints of the function execution. As you can see on the image, the SAND latency compared to AWS and Apache for a Python function interaction is a lot faster. So out of the 3 research papers given, this one was my favorite despite the fact it was my 5th choice. Reading the paper, everything was well structured and a very good and easy way to follow along and read. The researchers detailed every step they took through their evaluation. And finally, the researchers go over a future work section describing how SAND can be used for lighter operating system concepts, which I thought was very amazing. So thank you for watching.